This timber beam has been holding up a roof for 8 centuries, and it's stronger now than the day it was put in place. Meanwhile, the wood sitting in your garage, fresh from the store, perfectly cut, neatly stacked, has already started to twist, maybe crack, maybe bend just enough to ruin whatever you planned to build. That gap? It's not bad luck. It's not quality control, it's something we forgot. Because medieval builders weren't working with better tools, they weren't secretly more intelligent. They didn't have machines, moisture meters, or engineered lumber. What they had was a completely different way of seeing wood. To them, a tree wasn't just material. It was a structure before it ever became a beam. And if you didn't understand that structure, you were building failure into your project before the first cut. Before they even lifted an axe, they studied the tree. Not casually, obsessively. They walked around it, slowly, like someone examining a patient before surgery. The bark wasn't just texture, it told stories. Growth stress, disease, hidden tension. They looked at the branches, the angle they grew at, how they twisted, how the crown leaned under its own weight. Because a tree that looks slightly off on the outside is usually a disaster on the inside. Twisted branches meant twisted grain, and twisted grain inside a beam doesn't just weaken it, it turns it into a ticking problem. Something that might hold for years, then suddenly fail when it matters most. But here's the part that sounds almost ridiculous until you realize it works. They listened to the tree, not metaphorically. They knocked on it. Knuckles against bark, a simple tap. Then silence. A healthy trunk would respond with a sharp, clean resonance, almost like a drum. But if the sound came back dull, flat, dead, they walked away. Because that meant something inside was wrong. Rot, hollowness, internal fractures you'd never see from the outside. They could hear problems decades before they became visible. Today, we buy wood based on dimensions and price tags. Back then, they were diagnosing it. And that difference alone explains why something cut 800 years ago is still doing its job, while modern lumber barely survives a season. But even if you picked the perfect tree, that was only half the game. Where that tree grew mattered just as much as what it looked like. Medieval builders understood something that modern forestry barely pays attention to anymore. Trees are shaped by their environment in ways you can't fix later. A tree growing fast is not a good thing. It's a weakness. Trees on sunny, fertile slopes shoot upward quickly. Wide growth rings, soft, open structure, easy to cut, and easy to fail. But trees growing in harsher conditions? Those were the ones worth taking. North-facing slopes were prized above everything else. Less sunlight meant slower growth, and slower growth meant tighter rings, sometimes 5 times denser than trees growing in ideal conditions. Think about that. 2 trees, same species, same age. One grows fast and looks impressive, the other grows slowly, almost struggling. And the second one becomes dramatically stronger. We're talking about wood, where the grain is packed so tightly it resists bending, splitting, even moisture intrusion. Medieval builders actively searched for those uncomfortable trees, because hardship produced strength, and they didn't stop there. If a tree had been struck by lightning, rejected. Fire damage, walk away. Even if the damage looked minor, because they understood something most people still ignore. Trauma doesn't just scar the outside of wood, it creates invisible stress inside it. Microfractures, weak zones, internal tension waiting for the right moment to release. That beam might look perfect when installed. Then 20 years later, it fails without warning. And someone gets hurt. So they avoided risk before it even existed. The best timber selectors could do something that sounds almost impossible today. They could estimate how long a beam would last before it was ever cut. Not exactly, but close enough. Decades, sometimes centuries. And they were right often enough that some of their choices are still holding buildings together today. Meanwhile, we've reduced wood selection to categories. Grade A, Grade B, 2x4, 2x6. We don't ask where the tree grew. We don't ask how it lived. We just ask how fast we can turn it into something usable. And that's the moment the problem begins. Because even if you somehow chose the perfect tree, there was still one decision left that could ruin everything. Not how you cut it, but when. This is where things start to sound a little strange. Because medieval builders didn't just decide what tree to cut, they cared deeply about when they cut it. And not in a vague, seasonal way, they followed the moon. That probably sounds like superstition, the kind of thing someone brings up after a few drinks, right before everyone politely changes the subject. Except it wasn't optional. In many regions, cutting timber at the wrong time could get you expelled from your trade entirely. Your career finished over timing. And the reason is something we only started properly measuring centuries later. Trees aren't static. They move water constantly. Sap flows up and down depending on temperature, season, and yes, even gravitational forces. The same force that shifts entire oceans also affects how moisture distributes inside a tree. During certain phases of the moon, especially when it's waning, that internal moisture gets pulled downward toward the roots, which means something very simple, but incredibly important. The wood above ground becomes slightly drier. Not dramatically, just a few %. But that small difference, right at the moment the tree is cut, changes everything that happens next. Because wood doesn't stop changing after you cut it. It begins a long, slow process of drying. And the more moisture it starts with, the more stress builds inside as it loses that moisture. That's where warping begins, cracking, twisting. So if you start with even slightly drier timber, you reduce those risks from day one. Medieval builders didn't explain this with physics. They didn't talk about moisture gradients or internal stress distribution. They just followed results. And over generations, they noticed something undeniable. Wood cut at the right time behaved better. It stayed straighter, lasted longer, failed less often, so they locked it into their systems. Exact days, exact windows. No guessing. And then they stacked another advantage on top of it: winter. Trees in winter are dormant. Most of their moisture has already retreated toward the roots. Growth has stopped. Activity slows down. So now imagine combining both factors. A tree cut in winter, during a waning moon. That's about as dry as raw timber can possibly be without any artificial process. And they knew it. Meanwhile, modern logging doesn't wait for anything. It runs all year, non-stop. Because efficiency matters more than timing, but that means a lot of wood arrives already loaded with the exact conditions that cause problems later. It hasn't even been used yet. And it's already set up to fail. And then comes the part that completely flips how most people think about wood. Because today, if you bring freshly cut timber onto a job site, people assume something went wrong. Too wet, too unstable, not ready, send it back. Medieval builders would have done the opposite. They wanted it fresh, not partially dried, not processed, not prepared, fresh from the tree, sap still inside, fibers still soft, because to them, that wasn't a flaw, it was an advantage. Green wood, what we'd now reject, was actually easier to work with. Tools moved through it faster. Joints could be shaped with precision that would be exhausting to achieve in hardened, kiln-dried timber. But the real advantage didn't show up immediately. It showed up over time, because wood shrinks as it dries. Everyone knows that. But what medieval builders understood and actively used was how it shrinks. Not evenly, not randomly. Wood contracts more across its growth rings than along its length. That directional movement isn't a problem, unless you ignore it. They didn't ignore it. They built around it. Joints weren't cut to be perfectly tight on day one. That would have been a mistake. Instead, they were designed with just enough tolerance, just enough space, for the wood to move as it dried. Then came the key element. Wooden pegs, driven into those joints while everything was still slightly oversized. And then, nothing. No glue, no clamps, no metal, just time. As the timber slowly dried over years, even decades, the fibers compressed. The structure settled. The joints tightened. What started slightly loose became permanently locked. Not because someone forced it together, because the material itself did the work. It's almost like the building was slowly pulling itself into alignment. I've seen joints from medieval structures that you simply cannot separate without destroying them. Not because they were forced together with brute strength, but because they spent centuries tightening themselves. And here's the part that's easy to miss. This only works if you understand exactly how much the wood will move. Too loose, gaps form. Too tight, cracks develop. They had to predict the future behavior of a living material and get it right. Modern construction avoids that uncertainty completely. We dry wood artificially, force it into uniformity, and eliminate movement as much as possible. Faster, predictable, efficient, but in doing that, we also removed the possibility for the structure to improve itself over time. But even that wasn't the most extreme part. What really separates their world from ours is how long they were willing to wait. Because once the timber was cut, it didn't go straight into a building. Not even close. It sat. For years, sometimes decades. Proper air drying wasn't rushed. It followed a simple rule, roughly 1 year for every inch of thickness. So if you had a massive beam, let's say 12 inches thick, you weren't using it anytime soon. You were waiting over a decade, and they actually did it. Entire construction projects were planned around timber that hadn't even finished drying yet. Some builders were working with wood that had been cut before they were born. In large cathedral projects, it wasn't unusual for beams to be prepared by one generation and installed by the next. Think about that level of patience. You're not building for yourself anymore. You're building for people you'll never meet. But there was a reason this wasn't optional. When wood dries slowly, naturally over years, the internal structure adjusts gradually. The cells relax, tension redistributes evenly. There's no shock to the system, no sudden collapse of moisture inside the fibers, which means fewer cracks, less warping, and far greater long-term stability. Now compare that to how we do it today. Kiln drying, high heat, forced airflow, days instead of years. Efficient? Absolutely. But it comes at a cost. Because instead of allowing the wood to adapt slowly, you're forcing moisture out rapidly. The outer layers dry first, shrink first, and lock the inner moisture in place temporarily. That creates internal stress, invisible at first. Then, over time, those stresses release. Cracks appear, splits form, and once that happens, the damage doesn't stay cosmetic. Those cracks become entry points for water, for insects, for decay. Medieval builders avoided most of that simply by waiting, and even how they stacked the wood mattered. It wasn't just piled up randomly. Timbers were raised off the ground, spaced carefully, aligned with prevailing winds so air could move evenly through the entire stack. Not too fast, not too slow. Controlled, natural drying, no machines, just understanding airflow and time. And here's the part that should probably bother you. If you take the same species of wood cut from similar trees, air-dried timber can be significantly stronger than kiln-dried timber. Same material, completely different outcome, because one was rushed and the other was allowed to become what it was supposed to be. And even after all of that, choosing the right tree, cutting it at the right time, shaping it while it was still alive in a sense, then waiting years for it to settle, there was still another layer most people today completely overlook. Not all wood from the same tree is equal, not even close. To modern builders, a plank is a plank. As long as it meets the right dimensions, it gets used. Medieval craftsmen would have called that careless. Because inside every single tree, there are two very different materials hiding in plain sight. The outer layer, lighter in color, closer to the bark, that's sapwood. The inner core, darker, denser, that's heartwood. Same tree, completely different behavior. Sapwood is basically the tree's living tissue. It carries water, nutrients, everything needed for growth, which also means it's full of exactly the things insects and fungi are looking for. Moisture, sugars, nutrients. It's not just vulnerable, it's attractive. Heartwood is the opposite. Over time, the tree fills that inner core with chemical compounds, tannins, resins, natural defenses. It becomes harder, more stable, and far more resistant to decay. It's the part of the tree that has already fought off everything trying to destroy it. So, medieval builders made a decision that would seem wasteful today. They removed the sapwood completely, cut it away, discarded it, sometimes losing nearly half of the original log in the process. But what remained was dramatically more durable. We're talking multiple times the resistance to rot, insects, and moisture. Same tree, radically different lifespan. Modern sawmills don't separate like that. They cut for efficiency, maximum yield. Every usable board gets sold, regardless of where it came from inside the trunk. Which means sapwood and heartwood get mixed together. And suddenly, parts of the same beam start aging differently. One section stays solid, another begins to break down, and the failure looks random when it isn't. It was built in from the start. Medieval builders refused to take that risk. They didn't just understand wood as a material, they understood it as a system, and they made sure every piece they used had already proven it could survive. Because once that beam was in place, it wasn't meant to be replaced. It was meant to outlast everything around it. And that mindset shaped one final decision that modern construction almost completely ignores.